Hi everyone. In this video today we're going to look at division of polynomials. I think there'll actually be two videos for this. To begin with, we're just going to have a look at the basics. Now I've got 4 quick questions on the screen, and what I'd actually like you to do after this, I'll give you a little bit of time, but like pause the video at some point and get a scrap piece of paper and try to write down the answers to these questions, and we'll just see how you go. Okay, so pause the video now and I'll start talking again in a few seconds. Alright, so to answer these questions here, how many 4s are there in 20? Well, hopefully we all know that, right? So we know that there are 5 4s in 20. And the reason that we know that is because, well, 20 can be written as 5 times 4. So this here literally means that there are 5 4s in 20. We can use the same idea with these algebraic problems just here. So how many x's are there in x to the 5? Well, the answer to that is that there are x to the 4 x's in x to the 5. And again, that's because x to the 5 can be written as x to the 4 times x. So we can see that there are x to the 4 x's in x to the 5. You might think I'm a little bit weird for knowing this, or, well, even thinking about it, but I think that this is a really good way to sort of look at these problems. When we do the next one, how many x cubes are there in x to the 10? Well, there's x to the 7 of them. And that's because x to the 10 can be written as x to the 7 times x cubed. So that's just using the index law, the very first index law. The last one, how many x plus 2's are there in x squared plus 7x plus 10? Well, the clear answer is that there are x plus 5x plus 2's in x squared plus 7x plus 10. That one is perhaps not quite as obvious as the others. And the reason for that is that when we factorize this quadratic equation, we can factorize it using add to give, multiply to give. So two numbers that add to give 7 and multiply to give 10, and they would have to be positive 2 and positive 5. So we can factorize it into x plus 2, x plus 5. And so when we look at this, well, we can see that there are x plus 2, x plus 5's in x squared plus 7x plus 10, or vice versa, that there are x plus 5, x plus 2's. So this understanding comes in kind of handy when we get to actually doing division of polynomials. Before we get to doing division of polynomials though, what I want to do is jump into doing division just with standard numbers. So just to do a quick refresher of long division, which I suspect many of you probably haven't seen since, I don't know, year 7, maybe even earlier. So to do long division, the way that we set it up is we're trying to do 478 divided by 19. So I write the 19 here, I write the 478 here, and we ask ourselves, how many 19's are there in 4? And, well, the answer is clearly 0. It doesn't go into it. So that 0 occupies the hundreds column. The next thing that we do is we ask how many 19's go into 47. And the answer to that is 2. Now that 2 is occupying the tens column. Okay, so what we do at this point is we multiply that 2 with the 19, and it's really 20 times 19, because as I said, that 2 is in the tens column. So 20 times 19 is 380. And we take that away. So 478, take away 380, leaves us with 98. And then we repeat the process. So then we go, how many 19's are there in 98? And well, that's actually easy enough to solve. There are going to be 5 of them. 5 lots of 19 is going to be 95, which we take away. And that leaves us with 3, which will be our remainder. And so we can really say then that there are 25 and 3/19. If we're writing it as a mixed number. So that's the long division process. That's how I would work through them. You can always take this process further to get the decimal equivalents, but I'm not going to worry about that for the purposes of this lesson. So we actually apply this exact same process to dealing with polynomials. Now I've got a quick example here. So we're going to try doing x squared plus 10x minus 39 divided by x minus 3. So what I'm going to do is I'm going to write the x minus 3 out the front there, and then the x squared plus 10x minus 39. Now this is going to be a nice answer. I did pick a factor of the number, and I did it to just highlight how this process is going to work for you, make it nice and easy. So when we look at this, we say, well, how many x's? We don't really worry about the minus 3 because it's kind of insignificant compared to the rest of the equation. But we can say how many x's go into x squared. And if we go back to our previous answers up here, when we were looking at how many x's in x to the 5, we said that there were x to the 4. How many x's in x squared? Well, there are x of them. And then we multiply the x with the x minus 3. I'll keep track of that over on this side here. Now, this is just something that I do. It's not really formal working out, but it can sometimes make the process a little bit easier. If I expand that out, I get x squared minus 3x. So that's what I need to take away, and I'll just write it down here. I'll line it up with the corresponding term. So the x squareds line up, the x's line up. We're going to take that away. So just like we did in the long division process above. X squared minus x squared leaves nothing. So I don't need to write anything in this space here. Then we've got 10x take away negative 3x. Now, when we have take away negative, that makes it plus. So it's really 10x plus 3x, which is 13x. And this minus 39, it's not having anything subtracted from it, so it's just going to come down here. Okay, and we'll just write minus 39. Now again, drawing that arrow isn't formal, it's just showing you what's happening here. And then we start our process again. So we say how many x's are there in 13x, and the answer to that is that there are 13 of them. And so we multiply the 13 by the x minus 3, which gives us 13x minus 39. And I'll subtract that now. (13x) take away 13x is nothing. Negative 39 take away negative 39. Again, the take away negative makes it plus, so it's negative 39 plus 39, which is 0. And so you can see our answer up here. Okay, and so we can say that when we do x squared plus 10x minus 39 divided by x minus 3, that's actually equal to x plus 13. And I can show you another way to sort of think about that as well, right? So this one here worked out really nice because the x minus 3 was a factor of the quadratic. That won't always be the case, but if we were to factorize that quadratic first, the numerator would say x minus 3 and x plus 13, because negative 3 and 13 add to give positive 10, and they multiply to give negative 39. And, oops, don't know what happened just then. When I do that x minus 3 in the denominator, well, we can see that those x minus 3s would cancel each other out, just leaving the x plus 13. So that's, yeah, why I knew that the answer was going to be what it was, but I think that with enough practice you can get to sort of seeing that as well. Now I'm going to leave this video here, and we'll pick it up in the next one with applying this to like cubic equations. So I'll see you there.